So this workshop is going to be a very hands-on crash course based off the meme here. Nothing wrong with a rigorous academic introduction whatsoever, but tonight the goal is to just get up and running. So tonight we're going to learn what EDA is. So this workshop is going to be a very hands-on crash course based off the meme here. Nothing wrong with a rigorous academic introduction whatsoever, but tonight the goal is to just get up and running. So tonight we're going to learn what EDA is, and we're going to perform it on a real data set. We're going to learn how to run our first R program. We're going to learn how to code some graphs like this, and hopefully we're going to discover some insights about this data set that we have. But before we get too far, who am I? Why am I talking? I'm Leo Glowacki. I'm a 5th year here at Ohio State, double majoring in data analytics and music. I'm the BDA education director. I'm a certified RStudio instructor, so somebody thought it would be a good idea to say that I know how to teach this stuff. And I strongly believe that dogs are better than cats. Many quantitative techniques used, and that's because the whole purpose of EDA is to really look at and explore the data, and most quantitative techniques employ some sort of assumption about the data, which at this point in time we don't really know if it's true or not. So like I kind of hinted at, EDA, it strives to do a lot, but it's really about maximizing insight into a data set, and we want to learn what the underlying structure of it is. We want to know what the important variables are. We want to know if there's any outliers or abnormalities in our data. We want to test any underlying assumptions of the data, and we can use that to develop parsimonious models, which are just models that are simple but accurate in the best sense, and to determine optimal factor settings, which is more model tuning that's not important for now. So that means that EDA, exploratory data analysis, is this small step in the whole data science process. And it can be done in and of itself, but normally EDA is done when we want to go further than just the EDA. We want to build models and deploy them and things like that. And also from this graphic, you can see that typically data scientists perform EDA as well as data analysts. So today we're going to be looking at a specific data set, which if you want to look at as well, it's this link. And this is real data that was collected in 2005 to 2006. And it's from 2 public schools in Portugal in the same area. And the reason that this data was collected is because Portugal, especially in comparison to the rest of Europe, was just not doing as well in their schooling. And so they collected some data to figure out what was happening, especially in math and Portuguese. So, and there's actually this whole academic paper that was done based on this data by Paulo Cortes and Alice Silva about how to use data mining to predict secondary school student performance. And they wanted to do this because they wanted to answer 2 questions. Mainly, is it possible to predict student performance based off demographic characteristics? And if so, what are the factors that affect student performance? So like, does a mother's education level affect their students' performance? Or how many absences in the school year do they have? And so in the description of this data set, we can see that there are 30 different factors here that we can look at. So the student's school, their sex in this simplified binary way of looking at it, student's age, their address, whether or not they're in an urban or rural home, and things like that. And so we're going to look at the Portuguese data set, so their Portuguese class. So let's go ahead and just get started here. So I'll do this with you, but if you can go ahead and go to this link. Okay, so you'll be asked if you want to join the space. You'll join the space. It'll say, give you a little welcome message, and you should be able to look at projects. And you should see a project called Bootcamp. You should be able to click on it and start it. And it might take just a minute to deploy the project, especially with everybody kind of doing this at the same time. So no worries there, just be patient. And I should note, I do not recommend refreshing, as refreshing starts this process over again. So you could be here quite a while if you do that. All right, so then we're met with this sort of blank session here. And I've gone ahead and I've made an R file for us to work on already. And you'll see it's this EDA_workshop.rmd. RMD just stands for our markdown file, but nothing really to worry about there for now. So you can click on that, and then you'll see all of this stuff pop up here in this top left box. So this top left box is where you can write all of your code in R, which I should say that R is a programming language, and it's a programming language specifically designed for people who are doing data analysis, and especially people who may or may not have previous programming experience. So it is intended, especially for statisticians with no computer science background, to just be able to pick up and start doing data analysis with. And you can program in R in RStudio. This is a cloud version of RStudio. There is a version that you can download to your computer. And if you get into this, I highly recommend downloading that version. But for tonight, it's just easier to use the cloud version to get started. So to run all of this code, we can click knit here. And it's going to process this file. And a pop-up should pop up. If you do have a pop-up blocker, make sure you're checking that and allow it to pop up. And we'll see here that we have some of the code from earlier in this box. And we'll also see that we have this graph that was generated here. And then some other stuff later. So cool. That's our first running of R. And then this might be a little confusing now, and that's okay. But for this, just don't worry about understanding all the code right now. I will explain all of it very shortly. But first, just see if you can try and do this without fully understanding everything that's happening yet. So I'll send this in the chat so that when you go into breakout rooms, you can still see it. But basically go into the code and look at the first code block with the code here. It was actually the second code block, apologies. This code block here. And try and see if you can change the graph to let's see. Yes, thank you, Enan, for sending that in. To mjob on the x-axis, G3 on the y-axis, and filling it with address. So we wanted to put mjob on the x-axis. And so we have here that the x-axis was reason. So now we're going to change it to mjob. G3 is already on the y-axis. And instead of having sex as the fill, we're going to put address. So we're going to knit that. And we see that although I didn't change the title, all this display text here, which I could go back and fix. So by student school, mother's job, and address. Let's see, what was it? It was rural versus, oh yeah, it was rural versus urban. We can say, instead of X, so knitting again, we'll get our code to run. And yeah, so we see it's all updated here for the mother's job and whether they live in a rural or urban environment. Okay. So enough mystery about that though. How did we do this? So here was all the code again for that. But let's break it apart. So plots in ggplot, which is the package and function name that we're using to create all of this, they all consist of layers. And so approximately each line is a layer. And so you'll see I have in red what each layer is. The labs or labels layer is more than one line, but you'll see the parenthesis here and then at the end to start and end this layer. And then the theme dark is another layer. And so you'll see our first layer here just says ggplot and then student underscore poor. And this is our data. And if we look in our code from earlier, we can see that I imported the data here and I named it student underscore poor because it's the Portuguese student data. And we can talk about that more in another workshop, but for now, just know that's what the data is called. So our second layer is usually our geom function and our aesthetic values. So geom functions typically describe what sort of geometric thing that we want to put on the plot. So in this case, we wanted to do a box plot, and I'll show you other kinds of geom functions as well. And here we had AES, which just stands for aesthetic values. And the aesthetic values define important things about how the plot should look. So here we say, okay, X for our x-axis, we want it to be the reason for attending that school. We want Y to be G3, and we want the fill, which sets the color of those, to be sex. And So then all the rest of this is actually really kind of extra. It's really not necessary to create a basic plot. So what that means is we can take just this and get a plot that's going to be a box plot with, and actually I'll just go ahead and show you what this looks like. So I can literally just copy and paste this into another code block and then delete all of this extra stuff, making sure to delete that last plus because we're not adding anything else to it. And then if we run it, we'll see that this is a perfectly reasonable box plot. It doesn't look as good as this earlier box plot, but it is a box plot and it's a perfectly valid graph. And we actually get a lot out of this graph from just these 2 lines of code. So you can make things that are like really complicated and take a minute, but look good. But you can also just get some things out pretty quickly just by doing this. You'll also notice that I didn't hit knit this time, which I definitely could have done. There's 2 ways that you can run code in our Markdown. And so the first way is by knitting like this. You'll see the first graph and the second graph and the code for each. But you can also just run the code blocks by running it in the top right corner. But you have to be careful with this sometimes because the order is important. So it's always just safe to knit, especially if you're having any weird errors. I recommend just knitting. So, all right, so your turn again. We're gonna make another box plot and it should look just like this. And to do that, you're gonna put school on the x-axis, G3, final grade, and higher as the fill. And so remember, we can do this in just 2 lines of code. And I left space in the R Markdown document for you guys to just go ahead and put it in that last blank empty code block. I'll just do it really quick to make sure that everybody understands. So to start out, we write ggplot and we put the name of the data, which is, let's see, it was student core. And then we add a plus sign to create another layer. And also normally you can go down a line every time you add a plus, but it's also perfectly acceptable to write on the same line. It's just better for readability to go ahead and start a new line after every plus. And then we want to make a box plot. So we say geom box plot, and we declare our aesthetic values. We set x equal to school, set y equal to G3, and we set fill equal to higher. And then if I knit, it's going to process that. And scroll all the way down, it looks about right. Okay. Cool. So now the really cool thing is that with this formula, you can make practically any graph, which is what makes this such a cool and powerful tool. So you see we have our ggplot, we supply our data here in the parentheses, and then we add a geom function layer with our aesthetic values. And then if we want to get fancy, we can add the rest of this, all of this other fancy stuff, which it says not required. And normally the defaults are pretty good for this stuff, which is really nice. So I mentioned there's a bunch of other kinds of graphs you can make. Here's a few examples. This is by no means any or all of the examples. But as you can see, if we have one variable and it's a continuous real valued variable, then we can do density plots, we can do histograms, we can do QQ plots, we can do this, I think this is the cumulative distribution function. And if we have a discrete variable, we can do things like bar plots. And for plotting two variables, we can do a scatter plot, which is known as geom point. We can put regression lines over them by just simply calling geom smooth. We can do geom jitter, which is like a scatter plot, but the points are separated or jittered just a little bit, so that if there's one point on the graph, but it's actually multiple of the same points that are all exactly the same X and Y values, it'll actually separate those out apart just a little bit so that we can see that there's a lot of values in that one space. There's geom text, which will put labels onto the graph. And if we have a discrete variable and a continuous variable, then we can do things like geom bars or geom box plots. And those are just actually a few of the things that you can do. And actually there's a bunch of different visualization things that we can do. This page I think is a really great resource because it just shows you everything that you can do. And so for example, actually this is what I was talking about here. This is a geom point, a scatter plot. But if you change it to a jitter plot, you see that it's the same data pattern, but we can see more of the points because in this point here, there's actually several points there. Okay, so this workshop, however, is about EDA. And ggplot, R, and RStudio are just some of the tools that you can use to do EDA. So let's use those tools to actually do some EDA. So the first thing that I really want to do in my EDA is get familiar with my data. And when we talked about it a little bit, we didn't get into it too much. So you'll see here also in this bottom right-hand window, there is a text file called student.txt. And if we click on it to open it, we'll see it pop up in this tab here. And I'm just going to slide it so I can see it a little bit better. But so this is a list of all the attributes in our data set. And this is from the people who did this study. And so we see again, we have school, sex, age, etc. So here's all of our potential variables that we can look at, and here's what they mean. Also, if we want to view our data set, what we can do is you'll see over here in this top right-hand panel, we have our, it says data, and we see that we have our data set here, or our data frame. And it's student_report again. And if we actually just click on that, this data set viewer will pop up. And we can actually view this whole data set here. So we see school, sex, age again, and we can see all the values. And if we want, we can scroll and view the whole thing. So this can give us some sort of idea of things that we might want to look at in our analysis. So let's just look at something here. One might think that absences are probably highly correlated with one's final grade. So what I'm going to do is I'm going to insert a new code block just by hitting this insert button here. or a new code chunk. And I'm going to make another graph to look, I'm going to look at the final grade, otherwise known as G3 in this data set, and absences. So again, just to make any graph, start off with ggplot and the name of the data set. We add our next layer, and we know, so let's see, final grade is, it's on a scale, we can actually see here. Final grade is a numeric from 0 to 20. That's what their grading scale is, and actually 10 is the dividing line between pass and fail. And so for absences, if we look here, we see, let's see, absences. There's the number of school absences, and it's a numeric from 0 to 93. So that means we have two continuous variables. And so if we look here, we see there's a couple things we can do for when X and Y are both continuous. So let's just try geom point or a scatter plot. So we're going to do geom point for a scatter plot. We're going to declare our aesthetic variables by typing AES and adding parentheses. We're going to do, let's see, let's just throw absences on our x-axis and our final grade on the y-axis. I'm going to click run here just to run it real quick. And there does seem to be perhaps some sort of correlation here between absences and our final grade. But this graph looks a little suspect because it's, we know that from this, we can see there's 649 observations. So there's that many rows or that many dots, that many points. But I would say this is definitely a lot less than that, which means that some of these points are overlapping. So I'm actually going to change this geom. Instead of point, we're going to do jitter. And if I click on run again, yeah, okay, we actually see that there's a lot more points there. So this is a good example of when we want to use jitter versus geom point. But we also see that there's this smoothing thing we can do. And this is where things start to get really cool with ggplot, because what I can do is I can just add that geom smooth layer on top of this graph that we already have. I do need to redeclare my aesthetic values here, just so that it knows to plot a line over the absences in G3. And we're going to get a little message about the exact smoothing function that it's using. But as we can see here, there is something going on, maybe, but we're not totally sure yet. And we should also keep in mind that there's a lot of other things, a lot of other variables in the background that we're not looking at here. So let's see. So we've got about 7 more minutes before we want to start wrapping up. So let's see. Now, there's so many more things that we haven't looked at in this data set since we spent a lot of time just sort of learning how to make graphs in our EDA. So I'm going to give you all about 5 minutes to go into breakout rooms and to make your own graphs. I encourage you to look at this list of variables, look at, well, actually, you don't have this slide yet. Okay, so look at this slide, and just pick a couple things. Make one graph, maybe two graphs, based off the example slides and the other link that I sent, and see if you can find anything interesting about the data set or about the data in it, because that's what EDA is really all about. That went well for everybody. Actually, does anybody want to share their screen and show their graph from their group? And it's okay if it's like not done yet or there's nothing super crazy.
I have one. It's not impressive though.
Please, by all means.
Okay, give me 1 sec.
Yeah, I think I set up screen sharing, right? So let me know.
Yeah, it should work. Nothing incredibly impressive. This is just to see, I went back to the box plot again, and this is just to see whether people paid for like services outside of school, and if it had like an effect on the grade. And obviously there's a bunch of other variables that we don't know, but yeah, less variability on the yes side, but probably just because there was less data points more than anything else. I wasn't able to further explore, but.
Okay, cool, great. Thank you. Does anybody else want to share?
I can share mine real quick.
Yeah, please.
Also nothing too radical. I was just trying to find some sort of like expected trends. So I compared study time to final grades, and like this upper chunk looks like it's ever so slightly like positively correlated to more study time with higher grades. But then there's also this like interesting chunk down here where low study time is like low grades, and obviously, as you might expect, there's no one over on this side who spent 3 to 4 hours a week studying and also failed, which I thought was interesting.
All right, sweet. Thanks, Emily. Okay, cool. For the interest of time, I won't ask for any more. So as you can see, EDA in some respects is a very unstructured thing. And it's really just about discovering what we can about the data. And next week, we're going to do some machine learning on the same data set. And so our EDA is actually going to be really helpful for us when we're doing machine learning and seeing if some of these models are proper or not. And also in sort of predicting which variables we might want to use in our machine learning models. So just a little teaser there for next week. Does anyone have any questions so far? Or well, at the end? And if you don't want to ask them now, that's totally okay. You can always ask them on our BDA Slack, our learning community, or you can message me on Slack or through my website. And a couple ending announcements. Data.io 2020 is on October 3rd, and let me put a link in the chat for that. You should definitely check that out. it's doing EDA is a super applicable skill to it. So it's a great way to get hands-on experience doing some real EDA. So definitely recommend that, and that's on October 3rd. There's also a feedback survey for this workshop. It's only like 5, maybe 6 really quick questions. If you guys would fill that out, I would really appreciate that. And that helps the next workshop be even better. Somebody told me in the feedback survey last week that my mic sounded bad, and that's because I wasn't even paying attention. I was using the mic from my laptop. So I definitely read your feedback to make improvements and hopefully have better audio quality this week. There's some also further resources on this slide. I definitely recommend this first link if you're just getting started with R. And yeah, that about takes care of it.